All right, hey, what's going on, YouTube? Back at it again. So today we have container with most water. This is a LeetCode medium problem, and it has to do with arrays. So this is part of the arrays series. For this one, we're going to solve it with a two-pointers approach. So let's go ahead and read the description here. You're given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height sub I. Find two lines together that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay. So the input is a integer array that is height. Okay, so we know that. We see that here. And height at any index is the height of a line, which we can see in this graph here. So here's our example 1 and has a height of 1. And then if we look at the first index, we have a height of 8, so it goes to 8. Second index, 6, goes to 6. So we see that. N is height, it's length. So that's how many lines that we have. Each indice is the current line that we have, and the value at that indice is the height of the line. So we're looking for two lines together that can contain the most amount of water. And if we look at our example here, we see that that would be 1 and n. So we know the formula for area is we're going to do our length times our width. So that's how we know our formula for area. Okay, so given that, how can we find the max? Okay, so our first thoughts, at least my first thoughts, if I'm trying to find the max, would be brute force. And I feel like brute force would work here. And what I mean by brute force is if we come to this graph on the left here and we look at the first value, and then we do a second for loop, and we look at it compared to this value, compared to this value, compared to this value, compared to this value, all the way to the end. And then we move our indice up, and then we compare this value to every value past it. Then we compare this value to every value past it. We calculate a max. So for example, it would look something like, just for those of us that aren't as familiar with brute force approaches for problems like this, say I plus 1. So that's what the for loop would look like. So this first one would be height sub 0, and then this one would be start at height sub 1, and then it would go to height sub 2, and then we could compare here, and we would do our calculations, max calc, and then we would figure out whatever the max is for each one. So see how this visits, and it stays, just for those not super familiar with nested for loops, it stays at this original height, and then it calculates every value for it. And then once this for loop is done iterating, so this for loop's done, it breaks out because it meets this condition, meaning that J's visited every value. Then it breaks out of this loop, but remember, it's still in the outer nested for loop, so it'll go from height sub 0 to height sub 1, and then we redo the entire for loop logic again. So that's kind of how that works. So I think that would work. What we're looking at with that, though, is we're going to look at quadratic time complexity, so n squared. And I think that we can do better than that. So let's try to do better than that. Okay, so I did mention that we're going to use a two-pointers approach. So typically in a lot of problems where you have this sort of array, you can use multiple different approaches. A lot of them are going to be types of like pointer approaches, sliding window, two pointers. And for this one, there's kind of a trick to it. And the trick is that we always want to have the largest height that we're looking at. So what I mean by that is, say we're at index 1. Okay, this is the largest height, and we see our other 8, index 8, this is the largest height. But what I mean by the largest height is, let's say that we start, and so before I say the solution and how that works, my initial intuition when I thought of a two-pointers approach would be to start both pointers at the 0 index and then move the right pointer forward. And when we move the right pointer forward, if the right pointer height, say left and right are, and I'll type this out over here for explanation, but 1, 8, 6, 2, 5, 4, 8, 3, 7. So say we have our left pointer and our right pointer both at index 0. So they're both at 1. Move right, so now right is equal to 8. So if we ever find a value in which we can move our left pointer forward, we have to find a condition on which we're going to move left forward, right? So we want to move left forward any time that we can find a higher value. So left would also end up being 8. We do a calculation there for 1, the 8 for that, and then we move left is equal to 8. Now right's always going to move forward. Now right moves forward no matter what. So right moves to 6, then right moves to 2, then right moves to 5, and then 4 and 8. And left never moves again because left is always going to be at our greatest value. So we end up calculating 3, 7. We end up calculating all of these values. Now, eventually, using that method, it would work because we would see that we would calculate 8 with left, and then eventually as right moves through everything, we end up calculating the last value, so 7. So we end up doing that. So that does end up working. However, there are edge cases in which it won't work, and this is why we end up wanting to do this other route. Now, this other route is going to end up being, one, our left pointer is going to be all the way at the beginning of the array, and the right pointer is going to be all the way at the end of the array. So stay with me. We have a left pointer at the beginning, a right pointer at the end. We want to only move the pointer that has the lesser value each time. So when we look at this example, left has a lesser value than right, so 1 is less than 7. So we're going to end up moving the 1 inward. So now left is equal to 8. Now right is equal to 7 still. 8's greater than 7, so we move right inward. Then we move right inward again. But we've already calculated our greatest value with the 8 and the 7. But we end up moving these values inward until we can find a solution. So what does that look like? How do we code that out? So we'll go ahead and try to code that out and see how that goes. So the first thing we need is a max value. We'll put that equal to 0. And then we'll do our for loop. And I equals 0, I is less than, and I haven't done this, so this is, we'll have to see how this goes for me. I plus plus. Okay, so do I actually need to do a for loop here? Because I actually don't think I need to do a for loop, guys. So, and we'll put this in the same value. So what about left equals 0, height, or right is equal to height dot length minus 1, while left is less than right. So the condition where they're coming in, if left ends up overlapping, then we've already visited the values. Okay, so we need to do, while we're in here, we need to do a couple things, right? Need to do max height calculation. Need to determine which pointer to move. Okay. And at the end here, we will return max height. Okay, so let's do our max height calculation. So the first thing that we need to do is, so the container can only contain the lesser height value worth of water, because if we try to put water in, let's say over here, and it goes across, it's just going to overflow. So we'll say int min height equals math.min of height of left and height of right. So we want to use the minimum value because it's going to overflow for our area, that is, because this is going to be the best area we can have. Now, and max height doesn't make sense here. I actually shouldn't say max height. So best area. I mean, the function is called like max area, so we'll say best area. Okay. We'll say current best area equals. Actually, do we need to do a current best area? What about best area equal to math dot max best area? And we have our min height, so we need to multiply this min height times width, right minus left. Okay, I think that should work. Let's put this for PEMDAS in parentheses, so it does the calculation of right minus left before it multiplies min height times right and then subtracts left, right? Okay. So we have determined that we've calculated our math.max for our best area, and now we want to say if height of left is less than height of right, then we're going to want to move left forward, else right goes backwards. Okay, so let's try to submit this and see how this goes. Okay, it worked. All right, sweet. Yeah, so this was actually, kind of a hard problem when you don't think off the rip the best intuition, which is the left and the right side. But for this, our time complexity is O of n for visiting every single value, within n being the length of height. And our space complexity is O of 1 because we didn't have to create any new data structures of the size of height. So it's actually a really fast formula or algorithm that we have going on. And just to close out, I'll say that when you have any problem like this, try to think of, and when you've done these a lot, try to think of any scenario possible. So, and run through it with examples. So both starting at the beginning, one at the beginning, one at the end. Maybe there's, some other pattern where they're skipping. Eventually you'll learn and kind of think of all these patterns on your own, but before you give up, look at the solution, try to run through some of the patterns that you know and apply them to the problem, because a lot of times one of them will end up working. But yeah, so that's Container with Most Water. Appreciate you guys for watching. Like and subscribe. Thanks. Ooh.